Hey guys, about 2 years ago, I decided to write my own game engine using C++ and Vulkan. At the time, I barely knew any C++, so I decided to start from the basics. I read some books, I read one book, did some tutorials. Once I started feeling confident in my C++ skills, I moved on to learn Vulkan. After a lot of struggle, I finally had my first triangle on screen. Next, I made a cube that rotates in 3D space. I had to study a bit of linear algebra for that. Once I started getting the hang of Vulkan, I moved on to doing more complex things like loading a 3D model and rendering the scene in my engine with some lights. Every day, I was gaining more and more experience writing systems. Eventually, I wrote a real-time animation system by studying a chapter on 3D curves and splines from this one book called 3D Math Primer for Graphics and Game Development by Fletcher Dunn. And now I'm using my engine to make a 3D sci-fi game. I'll talk more about it at the end of this video if you guys are interested. But throughout this whole game engine journey, one thing I didn't mention is that I had to rewrite my engine a couple of times. Well, 3 times to be precise. Why? You see, initially I was just having fun seeing things on screen and I just wanted things to work, so it didn't really matter to me if my initial architecture was perfect or not. However, after some time had passed, I realized the need for having good, scalable systems in my engine early on. And so I did my first rewrite, and this time I did a much better job of writing the initial core architecture of my engine. But even then, I neglected something crucial, which was to learn CMake properly and implement a good build system. Initially, I was under the impression that my build system is a separate thing from my actual engine architecture, but I couldn't have been more wrong. At the end of the day, your engine is a library and it should be able to build and install on other platforms too. So for my third engine rewrite attempt, I actually took the time to learn CMake from the official CMake tutorial website. And now I not only have a much easier time in designing and implementing new systems, but I also have a much easier time integrating third-party libraries, which was a nightmare when I didn't know how to use CMake properly. Anyway, in this video, we're going to properly learn CMake and write a simple game engine project structure together. One with a good build system with clear separation of core libraries, and one with a good cross-compilation support as well. If you want to develop in one platform, say Linux, and if you want to compile for another platform like Windows, you can do that with cross-compilation. All right, guys, before we begin, I'd like to talk about the structure of this course. One thing I'd like to mention is that I'll be following this specific teaching pattern in all the videos. First, I'll teach a CMake concept, the theory, and then I'll give a practical example of how it's used, and more specifically, how I used in a game engine project setting. So I start with a simple project, and over time, I progressively turn it into an actual game engine project structure. The CMake setup specifically. By the end of this video, we will have a full game engine plus game project structure that I uploaded to GitHub already, and it's linked in the description. It doesn't mean that this course is not for non-game engine projects. This is absolutely a general in-depth CMake course, and all the things we learn about CMake will 100% be applicable for any kind of C++ projects. Okay, the first thing we're going to be talking about is the C++ compilation process, because a lot of the CMake terminology and a lot of CMake concepts depend on understanding how the C++ compilation process works. After that, we're going to be talking about CMake targets. This is probably the most important foundational chapter in this course because the modern way to use CMake is to use the target ecosystem. And we're going to talk about libraries and we're going to talk about how to build and install. And at this point, we're going to make a simple, tiny library. And I'll show you how you can use that library, how you can install that library, and then use it in a different executable. And then we're going to talk about how you can convert that into a library and then how you can integrate that library into another application. 1, using precompiled binaries, and 2, building everything from source. And then we're going to talk about different library types, static libraries, shared libraries, and object libraries, and other libraries as well. I'm only going to give you a basic overview at this point, and then we're going to slowly convert our example project into an actual game engine project. And then we're going to talk about CMake scope keywords, public, private, and interface. This is probably the most confusing part for many people who get into CMake. And I'm going to teach you in depth about what all of these mean. And I'm going to use all of these in different scenarios. And I'm going to show you how it all works. And then we're going to talk about the modern way to specify sources, which is target sources, and file sets. And you'll see why using file sets is a way better approach than manually specifying the include directories. And then we're going to talk about third-party libraries integration. I'm going to show you an example by using GLFW and building upon what I talked about before, which is linking the libraries two different ways. 1, using pre-built binaries, and 2, building from source. At this point, we're going to actually integrate GLFW, and we're going to see a working window on screen. And then we're going to integrate something called Vulkan loaders and Vulkan headers. And I wanted to show you guys how I used Vulkan in my engine. And I talk a little bit more about using options in third-party libraries. And then we're going to jump into packaging. where we talk about installing export targets and also how we can convert the engine into a package so that the consumers, the game app, can use our engine with find package and they can link to the targets directly. And then we're going to talk about how cache variables work and how you can provide your consumers some options to use. And we're going to talk about CMake presets, which makes providing all the cache variable information way easier. And then we're going to jump into an example of how we can use object libraries, and I'm going to talk about how it differs from static libraries as well. And then we're going to talk about compile definitions and something called generator expressions, and I'm going to give you a practical example of how I'm using in my game engine. And at this point, we have a complete game engine plus a game project structure that you can use as a skeleton or as a boilerplate to kickstart your own game engine journey. I'm also going to discuss about cross compilation, where if you intend your app to run on a different platform other than the one that you're developing in, for example, if you want to build apps for Windows or for Apple or for Android devices, I'm going to teach you how to do that with cross compilation. And then finally, I'm going to talk about my engine and my journey, and I'll talk about what's next for me. And then that's the end of this video. And finally, the focus of this video is not so much about the game engine itself, but instead the build system that goes into making any modern C++ game engine. All right, so let's get started.